Alright, what's going to be important in your reflections, the most important piece is when you're doing that FL is the one where you're flipping. But when you flip it, or another way to look at it, an FL could also stand for fold. You've got to fold that over a line. So the most important thing is going to be to know what that line that you're going to fold over is. So this is over the x-axis, or across the x-axis. Alright, so for me, I know, well, as an educator, I see that this is the most common mistake, but I know I've made this mistake as well. So first of all, know that they can give you the equation of the line. So the x-axis, the equation of that line, the horizontal lines are y equals. So my first step is always to kind of make that line nice and bold so I can visualize folding it. And then I will literally take my paper, I mean, what a reflection is going to be a flip or fold over that line, okay? But to define that, if you have a hard time seeing it, I want you to really take your paper. Now if you kind of stick your fingernail in the crease of that line and make a super careful fold, I want to show you that for a student that really struggles with these, you kind of hold this up to the light so you're sure that your grid is, you know, mine's not perfect here, but try and make my graph paper line up when I fold it. If that's an exact fold, that grid should line up really well. So my point is, if I have a hard time, you know, your lead on your pencil will smear on the other side. So if I were to take these points, C, B, A, I mean, what a reflection is, when I flip that, it's gonna, the definition of a reflection is those points will be equidistant on the other side. Now if I really push on my paper, we'll see if this works, I should be able to find exactly where those 3 points landed. So I don't know if you can see it, I can see it. There's one right here, there's one right here, and then this one is right there, because if it's on the line of reflection, it's not going to go anywhere. So to look at that one more time, kind of in slow motion, what did I do? I folded this, and if this was wet ink, visualize it going to the other side there. This is going to land the same distance on the other side of that line. Now distance is measured perpendicularly, so if I'm going to measure from point C perpendicular to the x-axis is going to be, I'm going to go vertically, right? This is a horizontal line, so I'm going to go at a right angle. Now the distance from the line of reflection, so count until you get to that line. 1, 2. So now I'm going to go 2 on the other side. 1, 2. And that's going to be where C goes. Now again, A didn't go anywhere because the distance is 0, right? So it's still there. Now B, again, I'm counting vertically to the line of reflection, okay? The line that I'm reflecting over, okay? So, or reflecting across. 1, 2, 3, 4. I count perpendicularly. I get 4 is my distance to the line. So when I reflect that, it's going to go 4 on the other side. 1, 2, 3, 4. And now I can draw my triangle. Okay? So again, a reflection is isometric. It's rigid, so your pre-image and image should look exactly the same. Alright, now most students are okay with horizontal and vertical folds or flips. It's the ones that have diagonal lines that can be tricky. Now this is a slope of -1 and a y-intercept of 0, so I know that's going to be this line. If I didn't know that, be resourceful please. If you're allowed to use a calculator, you're going to turn your calculator on, go to y equals, enter -x, hit graph. Well, that would be more helpful if I knew the exact point, so go second table to go into, look at some of those points. Oh yeah, 0, 0, -1, 1. Okay, now the more points you graph, the better. So again, just like over here, as soon as I see reflection, when I see the word reflect, that's really important to know what I'm doing. Don't rotate it if it says reflect it. I need to find the equation of the line, and then that's where I start. So now that I've found the line that I'm going to fold on, I want to make sure I'm very exact with that line. If I'm going to use the method of, making a very exact crease and literally folding my paper using, a hard lead so that when I push on it, I'm going to find where those points go. Okay, I know it's going to go down here, right? Equidistant on the other side. So I have to be really exact if I'm going to use that method, but you can try that and see how well it works for you. But let's again talk about the definition of a reflection. Each one of these points is going to go equidistant on the other side of the line of reflection. So here's my line of reflection, my line that I'm folding on, and I'm going to go to each one of those points. Now I have to go perpendicularly, so perpendicular to this diagonal is going to be this diagonal. The slope will be positive 1. Okay, 1 over 1, take the reciprocal, 1 over 1, change the sign. So it's just the other diagonal. So for example, point D right here, that is, count the diagonal. 1 point away, 1 distance, 1 diagonal, I should say, away. So perpendicular on the other side will be 1 diagonal, and that's where D is going to go. And I'm going to do that to 1 point at a time. I'm not trying to visualize this whole reflection at one time. Okay, my head's going to explode. 1 point at a time. The closer points for me tend to be the easier, so C. Now C is tricky sometimes for some students because sometimes if you hit it diagonally, you're going to hit it halfway. So this is half, so go half a diagonal on the other side. Okay, it's going to be equidistant on the other side of the line of reflection, or the line that you're reflecting over. Okay, let's look at B. B is a little tricky because there's a lot of stuff here. But you can put this on a separate sheet of paper and literally do 1 point at a time. Count your diagonals. 1, 2. That was 2 diagonals away. So 1, 2. Boom. B prime. Okay, and the last one, A. Actually, there's not much in the way. This one's not too bad. 1 diagonal. Okay, I'm folding over this diagonal and I'm going the other direction. 1 diagonal, 2 diagonals, half a diagonal. Oh my god, half! Start with the half, get it out of the way. Half is done. What was the whole number? 2, so I need to go 2 more. 1 diagonal, 2 diagonals. And there's A prime. And now I can draw my rhombus. Okay, every one of those points is the same distance. Perpendicular is how you measure from a point to a line on the other side. That's how you do reflections.